I'm using LOGO, a technique for splitting data to evaluate machine learning models. It's a type of cross-validation. I'll systematically leave out different parts of my data for testing. I have a small dataset with just 10 data points. Think of each data point as a single observation or instance. My data is organized into 4 groups. Notice that the group labels are not evenly distributed. Group 2 has 3 samples, while the other groups have 2 or 3 each. This refers back to LOGO, which is my method for dividing data into training and testing sets. I'm about to answer a multiple-choice question that tests my understanding of LOGO. This is the core question. I need to evaluate the different statements about how LOGO divides my data. Statement A predicts the total number of times I'll divide the dataset. Statement B describes what will be in each testing section that I'm creating. Statement C describes a possibility for the data that I'll use for training. I see that we have a dataset containing 10 individual samples. This is the data we'll be splitting using the LeaveOneGroupOut method. Here, I've provided you with the group labels for each sample. Notice that some samples belong to the same group. For example, samples 0 and 1 are both in group 1, while samples 2, 3, and 4 are all in group 2. The groups help structure how we'll split the data. We're evaluating our understanding of how LeaveOneGroupOut, abbreviated LOGO, splits this grouped dataset into training and testing sets. Statement A claims we'll have 4 different train test splits. LOGO ensures each unique group is tested separately. Because we have 4 unique groups, 1, 2, 3, and 4, we get 4 splits. Statement B asserts that each test set will contain samples from only a single group. This is the core function of LOGO, to leave out one whole group at a time for testing. Statement C suggests some of the training sets might include samples from all groups. Since LOGO only leaves out one group at a time for testing, the remaining groups will all be in the training set for that split. This makes Statement C true. Statement D states that each training set will only contain samples that belong to groups not present in the corresponding test set. This directly reflects how LOGO operates. It ensures the test and training sets are independent and mutually exclusive, with one complete group in the test and remaining groups in the training set. I'm using LeaveOneGroupOut, LOGO, a scikit-learn tool for splitting data in cross-validation. Think of it like this. I want to test my model's performance, but I don't want to use the same data for training and testing. That would be cheating. LOGO helps me fairly split my data, ensuring each part gets a chance to be both training and testing data. It's designed to handle data grouped into different categories. I have 10 different samples of data, like images, sensor readings, or anything else I'm trying to analyze. Each sample is unique and I need to split it into training and testing groups to evaluate my model's performance reliably. My 10 samples are sorted into 4 groups. Notice that Group 2 has more samples than the others. This is important because LeaveOneGroupOut will treat each of these groups independently. Since I have 4 groups, LeaveOneGroupOut will create 4 separate train test splits. In each split, one entire group will be held out, the test set, and the remaining groups form the training set. That's the key feature of LeaveOneGroupOut. Each test set contains data from only *1 group. This is different from other cross-validation methods which might split groups among training and testing data. Absolutely. Because each test set has data from only one group, the remaining groups automatically become part of the training set. So, it is possible that some training sets contain data from all groups except for the one used for testing. This is a direct consequence of how LeaveOneGroupOut works. I'll make sure the training data only contains samples from groups not included in the test data for each split. That guarantees a fair and independent evaluation. I'm using scikit-learn's LeaveOneGroupOut, LOGO, a special type of cross-validation. It's designed to handle data grouped into different categories. It helps ensure that the model evaluation is fair and accurate when your data has inherent structure. Because I have 4 unique groups in my dataset, groups 1, 2, 3, and 4, LOGO will create 4 separate train test splits. Each split leaves out one entire group for testing and uses the rest for training. That's what LOGO does. I have a multiple choice question that tests how well you understand Logo, and how it creates these splits. The question is based on a dataset with 10 samples divided into these 4 groups. My dataset has 10 samples, a nice small size to make things clear. The 10 samples are divided into 4 groups. Notice that some groups have more samples than others. Group 2 has 3 samples while others have fewer. This is key for understanding how Logo works. This statement is correct. Because I have 4 groups, I will get 4 train test splits. This is also correct. Logo's whole point is to leave out one asterisk entire group at a time for testing. Absolutely correct. Because each test set has only one group, the rest of the groups will be in the training sets. So, it's possible that a training set contains samples from every other group. Yep, that's the core idea. If group 2 is left out for testing, only samples from groups 1, 3, and 4 will be in the training set. I'm using LeaveOneGroupOut, Logo, a scikit-learn tool, for cross-validation. It's a technique I use to evaluate the performance of a machine learning model by splitting the data into multiple training and testing sets. I have a dataset with 10 samples. Think of these as 10 individual data points I'm using to train and test my model. These numbers represent group membership for each sample. For instance, the first 2 samples belong to group 1, the next 3 belong to group 2 and so on. This grouping is crucial for Logo because it controls how I split the data. This is the core of the cross-validation method I'm using. LeaveOneGroupOut means I'll leave out one entire group at a time for testing and use the rest for training. That's how it works. This is a multiple choice question that I'm going to answer based on my understanding of LeaveOneGroupOut and the given group information. I predict that because I have 4 unique groups, I will have 4 separate train test splits. One split for each group being left out as a test set. I predict that because of the way Logo works, each test set will only contain samples from a single group. That's the definition of it, after all. I expect that some of my training sets will contain samples from all the groups. This happens because Logo leaves only one group out during a split. The rest are in the training set. I expect each training set will only have data from groups that aren't asterisk in the corresponding test set. This is the fundamental principle behind LeaveOneGroupOut. It's super important. I have 10 data points, each representing a different sample in my dataset. This is the total number of observations I'm working with. These numbers tell me which group each sample belongs to. For example, the first 2 samples are in group 1, the next 3 are in group 2, and so on. This is crucial information for my LeaveOneGroupOut, Logo, cross-validation process. I'm using a specific cross-validation technique called LeaveOneGroupOut. Logo ensures that each group is tested separately, making it suitable for datasets where groups represent some important factor. Logo is a type of cross-validation where I separate my data in a specific way. I'm setting aside one entire group at a time for testing and using the rest of the data for training. This helps to make my model evaluation more robust, especially when dealing with group structure. Because I have 4 distinct groups, 1, 2, 3, and 4, in my data, the LeaveOneGroupOut method will produce 4 different train test splits. Each split will leave out one group for testing and use the remaining samples for training. That's pretty cool. This is an abbreviation for LeaveOneGroupOut. I use it to help me build more accurate models by considering data group structures. It's a technique that's quite useful in various machine learning projects. This is the core of the problem. I have to analyze how my chosen cross-validation method will affect the composition of training and testing sets in my model and choose all statements that accurately reflect that composition. I'm dealing with a multiple-choice quiz question about the LeaveOneGroupOut method.